Hi everyone, this is MathsForUni. We'd like to discuss the important topic of pure versus applied at university. It's likely that you already have a preference of one over the other, but I challenge you to throw that out the window for the next few minutes. Let me begin this discussion by giving my own personal mathematical journey. Before university, my passion for mathematics came from my experience of the pure side. This is because the pure content for me at the time was essentially just calculus. Sure, there were other topics around it, like trigonometry, exponentials and logarithms, but to me, these topics just helped me solve various calculus problems. In fact, when I took the STEP exam, of which a high grade was part of my conditional offer to study at Cambridge, I practiced and eventually in the exam answered only pure style questions. It may therefore surprise you that since my first university lectures, I've been leaning more and more towards the applied side. To this end, I now specialise in theoretical physics and other particular areas of applied maths. This is not uncommon. As another example, I have a friend who absolutely hated statistics before university and is now doing a PhD in the field. To completely oversimplify and provide a general point to keep in mind, the pure mathematics that you've likely studied before university will become the applied mathematics of university. The so-called pure techniques that you've built up over the last few years become applied to problems in different contexts. Pure mathematics at university just appears out of nowhere, unless you've already studied groups or perhaps seen the epsilon delta definition of continuity. Even probability and statistics, which you may have considered very applied previously, can take on a much more pure form, where you may discuss the axioms of probability and probability measures and spaces. It's worth keeping in mind that you can study any subject from different perspectives. Take a differential equation, for example. An applied mathematician might have obtained this differential equation from some kind of context. Perhaps it models the motion of a boundary layer of a fluid, or a wave function in quantum mechanics, or the population dynamics in predator-prey interactions. Ultimately, the applied mathematician wants to get the solution, or, if this isn't easily possible, use techniques to try to understand the general behaviour and properties of the solution. The pure mathematician, on the other hand, sees the same differential equation and might want to prove rigorously that the solution is unique, given some initial or boundary conditions, or that solutions exist and are smooth within some domain. See the Navier-Stokes Millennium Prize problem, for example. Neither of these pursuits are immediately better than the other. Both perspectives are valuable, and there are many fields in mathematics where pure and applied can come together to work on problems. If you're considering buying our course, then take note that we have grouped our lectures by pure and applied in the contexts that you would see them at university. As such, keep an open mind when watching the videos. Rather than sticking with what you think you prefer, you might just surprise yourself. I hope you've enjoyed this video and goodbye for now.